normal distribution. There's just a couple examples in this video. The only package we need is Mosaic because we're not really working with data sets. So in this first example, mean cholesterol level of people in Nigeria was 193.9 milligrams per deciliter, with a standard deviation of 57.8 milligrams per deciliter. This is based on some research. Assume that cholesterol levels are normally distributed. So the first thing you should do is state what your random variable is. What did you actually measure in this case? So in this case, we were measuring cholesterol level. Notice it's not the mean cholesterol level, it's just the cholesterol level. And it's just people in Nigeria. So try to be as specific as you can when you're doing these. Now we'd like to find the probability that a person in Nigeria has a cholesterol level above 240 milligrams per deciliter, considered a high level. So it's good to rewrite this in a mathematical statement. So we're looking at the cholesterol is going to be greater than 240. So that means we're looking at being on the upper end. I'm going to go ahead and put an R chunk in. The command we're using the normal curve. So this is P norm. Again, if you start typing it, it will fill it in for you. If you look at this, it tells you you're going to start with your Q. That Q is the number inside your parentheses. This is going to put in your mean and your standard deviation, which we have to go get from our problem. And then it asks you if the lower tail is true or false. So we are starting at 240. Our mean is 198.9. It's right up here. And our standard deviation is 57.8. And then the lower tail, well, we want upper. We want to go on the upper side. Lower means it's down to the left. Upper means it's to the right. Therefore, the lower tail, which is on the left, is not being shaded. So that means we're false. And then we can run this, and you can find out what value you get. Another nice command, by the way, is to put an X in front of the p-norm. And what's nice about that is it actually draws your picture. So you can actually see that you are a greater than, can see you're actually in the upper tail. And it's just a nice way to look at visualizing what's happening. So it's a good way to confirm your answer. And then you can see your probability of being greater than 240 is that 0.2385 that we got before. So it's just a nice way to do that. Let's find the probability that a person in Nigeria has a cholesterol level below 299 milligrams per deciliter. This is considered a desirable level. So we're looking at cholesterol being less than 299. Again, we will put an R chunk in. I'm going to go ahead this time and just go with an X P norm. And then my Q value was at 299. My mean is still the 198.9, and my standard deviation is 57.8. So that doesn't change. So I'll just copy and paste them. And then my lower dot tail, since we're below, this one is actually true. Again, running that, you can see we're looking at the lower tail here. And you find that number. So again, lower tail. In this case would be the purple area, this lower tail you're looking at. And the answer is the 0.9583. So 95% of people in Nigeria have a good cholesterol level. Now find the probability the person in Nigeria has a cholesterol level between 200 and 238. It's considered borderline high. So we're 200 is the lower. Then the cholesterol level is somewhere between there. And it's going to be less than 239 because we're between those two values. So in this problem, it's a little bit more work to do this. And I'm not going to use the XP norm this time. I'm just going to use the P norm. And what I want to think of it is I'm going to be less than the 239. So let's start with that one, less than the 239, with my same mean and my same standard deviation. And the lower dot tail is true because we are saying we're less than it. So there's one value. Now I know we want to be greater than the 200. But if we did that one as lower tail is false and go upward, we're getting everything from 200 up, we're getting everything from 239 down. We're not going to get the things in between. So what we need to do is take the 239 and then subtract off the 200. So we're going to subtract off the P norm of 200 with the same mean, same standard deviation. And again, our lower dot tail in this case is in fact still true because we want to subtract off that lower tail from what we have. Run that and you find that it's about 25% of people in Nigeria. If you found a person in Nigeria having a cholesterol level between above 240, what would you conclude? So let's go back and look. What was 240's value? So 240 had a value of 24%. So 24% of people in Nigeria have high cholesterol. So I wouldn't find it all that unusual if that happened. And there'd be nothing to really conclude. So it's not unusual. And you wouldn't actually come up with anything. I just can't spell the word unusual. There we go. All right, the last question on this one is what value do 5% of all people in Nigeria have a cholesterol level less than? So in this case, what we're looking for is we've given you the probability in this case, and we're trying to find the data value. So instead of using P norm, we're going to use Q norm. Q norm gives you the data value if you have the probability, whereas P norm gives you the probability if you have the data value. So this is undoing it. We are looking at 0.05, 5% make that into a decimal. And notice it does say P and then it gives you your mean, and our mean and standard deviation are exactly the same. And then our lower dot tail is true because we again want people less than. So we're still in that lower end. So that means we are true. And so 5% of Nigerians have a cholesterol level less than 103.8, or if you want to go 103, 104. And the units, remember, were milligrams per deciliter. Here's another example. In example 2, in the United States, females eat on average 72.2 grams of fat every day with a standard deviation of 42.24 grams. This is from the USDA. The amount of fat a person eats is not normally distributed, but is relatively mound-shaped. So we're going to go with, we can use a normal distribution. I do want to point out that in the last example, cholesterol was told that it was normally distributed. This one is not exactly. So the values in example 1 were kind of approximates. These are even more of approximates because we're not exactly normally distributed. We are mound-shaped, but not exactly correct. So we're going to take some of these answers a little bit with a grain of salt. Our random variable is the amount of fat eaten per day of a female in the US. So notice again, I was trying to be very exact in my wording to explain to my reader exactly what I'm dealing with. Now find the probability that a US woman's daily intake is more than 100 grams. So we're looking at the probability the amount of fat is greater than 100 grams. So again, inserting my art chunk, I'm going to use the XP norm so I can just see what graph it looks like. XP norm, there we go. Again, it's going to tell me put in that Q value. So I'm going to put in that 100. That's that value that's inside that parentheses. My mean in this case is 72.2. My standard deviation is 4.24. And my lower dot tail is false because again, we're more than, so we're on the upper end. We're not down here in the lower tail. We're greater than, so we're up here on the upper tail. Notice my upper tail is shaded, though you can't really see the shading because it's so small. And if you want to find the probability, that probability is really, really small. So again, this is 2.75 times 10 to the negative 11th. Really small number. All right, find the probability that a U.S. woman's daily fat intake is less than 60 grams, sorry. So that's the probability that the amount is less than 60. So an R chunk, oops. Click in the R chunk, P norm. And I can do an XP norm just to see what it looks like. And again, I'm going to put in my 60, my mean, which I've forgotten what they were. So I'm going to go copy them, my mean and standard deviation. I go copy them. And then my lower dot tail is equal to true in this case, because we're saying we're less than. So we're in that lower tail. We're actually down here. Again, the graph will kind of show us this. We're down here in that lower tail. So you can kind of see where we are. You can see where that probability is. It's small. It's pretty dang small. It's not as small as the other one, but it's pretty small. If a woman claims that she eats less than 60 grams, what would you conclude? Well, that's a pretty small number. That's pretty unlikely that she did this. And so I probably wouldn't believe her. It's pretty unusual. So you may not believe her. It also may not be healthy. So you may, if this is true that she does this, you may want to talk to her about the fact that you do need some fat in your diet. So those are the other things you might want to do. You might want to counsel her. To eat more fat for health reasons. And I can't spell. This is why I like having spell check. Okay. Then what daily fat intake does 42% of US women eat more than? So we're looking again at, we've given you a probability and we want to find that value. So we want to find the value of the amount is more than, is greater than something. And that probability we know to be 42%. So into my R chunk. This one again is using the Q norm. My p-value is a 0.42. My mean and standard deviation are the same. And my lower dot tail, because we're greater than, we're above, so we're going to be false. So you come up with 73%. I'm sorry, 73 grams. So then we would say 73 grams is the amount of fat intake that 42% of all US women eat more than. Now, remember, we weren't sure we had a normal distribution, so these answers are just approximates, but they are close to, hopefully close to what we think. This is real data that was gotten, so I just wanted to give you the references for it.